Vicky Shaman. Hey, today I'm going to present the question 4A1 in Mock 1. In this question, we can see that random sample is 200, which is n, and he found that 50 would be willing to stock a proposed new product, which means that 50 is x. So that's n is equal to 200, x is 50. While in the question 4A1, we are going to find the population proportion, so that P is equal to 50 over 200, which is 1/4. And in these questions, we need to use the formula that is P plus or minus Z alpha over 2 times P times Q over N, so that we can use all the information to find out what is the population proportion, so that this question P is equal to 1/4 plus or minus Z 95%, 1 minus 95% is alpha, so that in this question, alpha over 2 is 0.025 times 1/4 times 3/4 over n is 200. We need to find out what is Z 0.025, so we need to use this table and find out that 0.025 is 1.96, so this is 1.96. The calculation is done. We can find out that P is between 0.18999 and 0.3800.
Hello everyone, I'm Lin Hongming, and I'm going to talk about the question 4A2. Let's look at the question first. The question asked us to find the size of sample, which means that we need to find out the unknown n. Also, we can know that the confidence is 95% and his error of estimate does not exceed 0.04. Combine the data we have, we can use the formula error equals to set open bracket alpha divided by 2 close bracket multiply open bracket boost P multiply Q divided by n close brackets. As we know that the confidence is 95%, then we can use 1 minus 95% to find out the alpha. Then we can replace our data. However, we do not know the value of P multiply Q. To maximum the n, P multiply Q should be minimum. So we use 1 divided by 2 to replace P. But we still have the unknown set. Then we can look at the normal distribution table and find out the value, which is 1.96. Then we can replace all the data we have. To calculate easily, we can change the subject to n as we are going to find the n. Then we can calculate the answer, which is 600.25. The outlooks cannot have decimal number, so the answer should be 601 as we are going to find the maximum. This is the end of my presentation. Thank you.
Hello, I am Yan, and I will talk about question 3D. The daily revenue of a boutique is normally distribution with a mean of $10,000 and a standard deviation of $2,000. Assume that the boutique works 7 days a week. What is the probability that there are 2 weeks in 4 non-overlapping weeks that the average daily revenue of the boutique is between $8,500 and $12,000? First, I will let X be the daily revenue of the boutique, and I will use normal distribution. This is the mean of the daily revenue of the boutique, and this is the standard deviation. The standard deviation of sampling distribution mean will be divided by 7. The probability of the daily revenue between $8,500 and $12,000 will be in the equation of this. $8,500 minus $100,000 over the square root of the standard deviation, and $12,000 minus $100,000 over the square root of the standard deviation, and we will find that the value of z is between negative 1.98 and 2.65. From the table, we can see that 1.98 is equal to 0.0239, and the 0.65 is 0.00402. So we can find that the probability is equal to 0.97208. Then I will let y be the number of weeks with average daily revenue between $8,500 and $12,000 out of 4 weeks. And I will use binomial distribution. This is the number of weeks, and this is the probability that the daily revenues between $8,500 and $12,000. As the number of week is 2 weeks, so y will be equals to 2, and the equation will be 4c2 times 0.97208 in the power of 2 and times 1 minus 0.97208 in the power of 2, and we can find the answer 0.0044.
Hello everyone, I'm Yu Mingto, and today I'm going to talk about the question of mock paper 2, question 1D. And this question is about construct a 99% confidence interval for the mean percentage of revenue spent by all computer software company on research and development. For the solution of this question, we should first know that the confidence interval is 99%, and then we should now find out the mean and SD of the random sample. After that, we should determine that whether X is a normal distribution, and we know that the n of this random sample is 15, which is larger than 13, so we can determine that X is a normal distribution. In this case, we should note that we have only the standard deviation of the random sample, but not the whole population. But in this case, we can use the random sample SD to replace the whole population SD in the following equation. So now on, we can use the equation of the confidence interval, and in this case, we have found that n is larger than 13 and X is a normal distribution, so we can determine that we use the equation which is about the normal distribution one. So as we have listed out the equation, we can put all the information we have found above into the equation, and lastly we have unknown left, which is the Z, and we can use the normal distribution table to find out the value of the Z. And after we have found out the value, we can calculate the equation easily, and finally we can have the answer here, and the answer is X is between 7.7292% and 8.9948%. This is the end of my presentation. Thank you.
Good afternoon, I'm Joshua Wen from Group 4, and today I'm going to talk about the mock examination 1, question 3A, part 3. The sales amount of invoice of a certain company is normally distributed with a mean of 50,000 and a standard deviation of 5,000. In part 3, is a random sample of 25 invoices is selected. What is the probability that the total sales amount of the sample is less than 256,000? It's given that the mean is equal to 15,000 and standard deviation is 5,000, and let X be the total sales amount of the sample. And it's also given that the random sample size is 25. So sample mean is 50,000 and its standard deviation is 5,000 divided by square root 25. And now find the probabilities of that x bar is more than 256,000 divided by 25. And according to this equation, z is smaller than 2,056,000 divided by 25 minus 15,000 over 5,000 divided by square root 25, and it's calculated as negative 4.76, which is close to 0. Thank you.